Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. The heat of combustion of a compound increases with the number of carbon atoms and hence molecular weight number of CH and C to C bonds that can be oxidized. Additionally, ring strain contributes to higher energy content and thus higher heat of combustion. Moving on to the next step. Count the total number of carbon atoms in each compound. Ethyl cyclopentane, I-cyclopentane ring, 5C, plus ethyl group, 2C, is equal to 7 carbons total, C7H14. Ethyl cyclohexane, 2-cyclohexane ring, 6C, plus ethyl group, 2C, is equal to 8 carbons total, C8H16. Ethyl cycloheptane, 3-cycloheptane ring, 7C, plus ethyl group, 2C, is equal to 9 carbons total, C9H18. Moving on to the next step. The heat of combustion is primarily determined by the number of carbon and hydrogen atoms. More carbons and hydrogens mean more bonds oxidized and more energy released. 3. C9H18 has the most carbons, so it releases the most heat. 2. C8H16 has the second most carbons. C7H14 has the fewest carbons, releasing the least heat. And for the final step, consider ring strain contributions. Cyclopentane has moderate ring strain, cyclohexane has essentially no ring strain, chair conformation, and cycloheptane has moderate ring strain. Ring strain adds to the internal energy of the molecule, slightly increasing heat of combustion. However, the dominant factor is the number of carbons, molecular size. The ordering by carbon count gives 3 to I. Even accounting for ring strain corrections, the number of carbons dominates. 3 to I in heat of combustion. Why other options fail? A. 2I3 ignores the greater number of carbons in 3. B. I2-3 reverses the correct order entirely. D. 3I2 incorrectly places I above 2 despite 2 having more carbons. Therefore, the correct answer is C. Therefore, the correct answer is option C.